Looks like the current meter has reached the red zone. Only one thing to do: build a bigger power supply. Looks like the eBay gods have smiled upon us. Here we have an HDD 15-5-A plus G power supply. This example is a Condor brand made in 1990. Similar supplies are available new today. It's a 5 amp 15 volt or 12 volt split supply. To select 12 volt operation, jumpers will need to be repositioned in the supply. Let's start this build by taking this unnecessary bracket off the side. Then adding a power cord socket to the holes already in the chassis. Next, some rubber feet so it doesn't slide around and scratch up the table as much. I was initially going to use this switch, but then I saw the current rating was only half an amp, so it was off to the hardware store to get a better switch and some other bits, including an inline fuse holder. Never do anything with AC power without some overcurrent protection. First bit of soldering will be to move the jumpers W1 and W4 to W2 and W3. The original jumper wires got mangled good when I pulled them out, so I used some fresh wire to reinstall the jumpers in the new positions. Next is attaching the ground lug from the power socket to the chassis. I know it should be a green wire instead of orange, but I didn't have any green wire of the appropriate gauge. Now to put in a switch with the proper current rating, like this one. Once mounted to the chassis, the inline fuse can be used to attach the hot lead of the power socket to the switch. A wire is attached from the other side of the switch and goes to the transformer, which was already conveniently wired for 120 volt operation. I only had to remove some wire stubs left over from the previous equipment this supply was pulled from. The next mains connection is from the power transformer back to the neutral connection on the power socket. Now to remove the leftovers from the output connections. The sense connections need to be temporarily attached to the positive-negative outputs, otherwise this supply will output 0 volts. And with a flick of the switch, the supply powers up. And the voltage is set using a multimeter. I was able to get 12.00 volts on both the positive and negative rails with no problem at all. To make this power supply finger safe, an enclosure is needed, so I started by mounting some quarter braces to the ends of the chassis. Note that the transformer protrudes past the edge of the chassis, With this mounting hardware in place, I can measure for a piece of acrylic to cover the side, which will slide in like this. Later I will drill and tap mounting holes to match the corner braces. The top plate I cut out on a laser. You get a perfect flame polished edge every time. The cutouts are for amp meters and power connections to the rack. With connectors and amp meters mounted, the top plate slides into place and is secured with nuts and screws. Now we need to do some electrical trickery to get the positive amp meter to work. These amp meters measure current on the low side of a DC circuit. This is fine for the negative power rail. We can hook up the amp meter just like in the schematic provided, using the ground as the positive power feed and the negative 12 volts as the negative. To meter the positive rail, we need an additional positive voltage source to power the amp meter that does not influence the power delivered by the power supply. The way I solved this was to add a small additional transformer to provide floating isolated power to the meter. This 12 volt 1 watt transformer is mounted to a piece of phenolic and attached to the main transformer here. A full bridge rectifier circuit with a smoothing capacitor is built onto the phenolic plate as well. This assembly is bolted to the main transformer using the main transformer's mounting hardware. Next, the power leads are connected to the main transformer. And a little heat shrink for safety. Now attaching to the included leads to the amp meter. The positive sense connection is attached to the positive output terminal, and the current meter leads attached from the power supply through the amp meter to the output terminal, mounted on the acrylic. The ground output connection is added next. Followed by the sense wire for the negative rail, and the current meter connections. Note that the polarity of the amp meter leads on the negative rail is opposite the polarity of the amp meter leads on the positive rail, and the red current meter connection is attached to the output jack. The red small wire used to power the amp meter should be connected to the ground connection of the power supply. Now I added some length to the power wires for the positive amp meter and attached them to the filter capacitor on the small isolated power supply I mounted earlier. And with these connections, power supply is done. Now with some proper fire suppression, it's time to power it up and see if it smokes. Success, and no smoke. Now to check the amp meters. I used a 4 ohm 100 watt resistor. The amp meters are calibrated off camera. And here we have the completed supply with the acrylic side plate mounted in place. And finally, we have the power supply behind the rack doing its thing. Hope you all enjoyed. Thanks for watching.